Hi, my name is Uriel, and I would like to introduce you to the software called Micrometry. This one is the latest release that I have created, and its purpose is to have a tool that allows us to take measurements using the software Python and having access to a microscope camera. So in this tutorial, I'm going to show you how to navigate the program, and I'm going to show you how to install it as well. Among other things, we also need to talk about the equipment that may be good to have. I'm going to introduce you to some links where you could get some additional hardware that could help you in your projects. So let's start with the setup. The first thing that I like to show you here is my microscope setup. The first thing that we can notice is that I am using a modified version of a GoPro. However, your camera setup may be quite different. The only condition that you need to meet is that this camera can be perceived by your computer as a webcam. And for that to happen, you sometimes need to tweak or find some tricks around your technology. In my case, the GoPro, which produces resolution of 4K at 60 frames per second, can be read by this card called the CamLink. What they do is basically receiving the output of a camera and then transform it into an input so that your computer can read it and can then process it. We're going to need this for our program. The other option that you have is to use a software called DroidCam, which is actually what allows me to transform my phone into a webcam as well. So you can get a phone and then you can take it apart and keep the webcam. And from there, you can connect it directly via Wi-Fi into your computer as a webcam feed. Let me actually show you how the GoPro looks like. First, I'm going to fire my microscope. I am using a very old refurbished size microscope and using my GoPro. The most important thing that I need to keep in mind is to have access to a micrometer. Micrometers are reasonably cheap as well. Sometimes you find them for as cheap as $15. From AliExpress, and then you will have to wait for a month or something and it will eventually get to you. This scale bar is necessary to have an idea of how many pixels represent a particular unit of measurement in our program. Now that we have an understanding on what equipment we need, we can look into the GitHub repository. To clone a project in GitHub, you need to first go to this website. You should find a link attached to this video that doesn't take you to the repository, but rather to my website, my personal website. And the reason why I do it like that is so that I can keep some sense of statistics on how many people have been downloading the program. So I apologize for the extra step and inconvenience, but it's just a nice way for me to have a way to quantify the success of the program. So once you find the repository, you could of course type it directly. You need to clone it. You click on the green button here, and then you click in the copy URL to clipboard. There is multiple ways to clone a repository. I'm going to be using the HTTPS. I click here to copy it, and then I can simply go to somewhere in my computer. I will call this folder test. And here, if you're a Windows user, you can click Ctrl-L and enter the path. And in there, you can type CMD for command prompt, and that is going to open you the terminal. Here, I just need to make sure that I have Git installed, and I do. That will allow me to clone directly using a secure connection. So I can just type git clone, and then I can right click. Remember that the terminal is not the standard user interface. It doesn't allow you to do some conventional text editing. And once I have it, I can simply press enter. That will clone the repository. The repository is not heavy at all. It's a very simple program. It was intended that way. It's 2.25 megabytes or so. So once you have it, you will have the program right here, ready to fire it up. In the folder examples, you will find the image that has been used for the GitHub repository. Nothing special in there. And here you have another two subfolders. There is measure curves and there is measure lines. Measure lines is intended to be a program that is very, very simple. No frills at all. It is just a program that shows you a camera and allows you to access a scale bar and then a line. Nothing else. So if you are only working with straight lines to take measurements of segments, for example, or the diameter of eyes in spiders, perhaps this is the only thing you need. So I suggest you to just use the simplest tool. First, let's look at the measure lines tool. To run this, you will probably need to create a virtual environment. And the reason for it is because we are using two main libraries. The first one is called Pygame, that allows us to create an interface that creates screens and a user interface. And also we use the library known as OpenCV. OpenCV is an incredibly powerful tool as well that allows us to read the webcam. In my case, I have the software called Anaconda. If I type Conda here, you will see that it's already attached to my terminal, and Anaconda is what is known as an environment manager. What it does is basically install for you in an encapsulated way all of the infrastructure in terms of software that you need to run Python and other programming languages. And to get Anaconda, you just need to type Anaconda and go to the installation tab. Make sure to choose the right operating system. And once you have it, you will be able to install environments. A detailed explanation on how to install the environment will be attached to this README file in the repository. So I'm going to move to the next step so that I don't make this longer than it has to be. You can go to the main.py file. Everything else here is just a support to the main file. If I double click on it though, you may find out that it gives you an error. In my case, the error is caused by the fact that I am not running this main.py file directly through my environment. So I need to activate that environment. Let me show you how to do that. Let's open this folder through the command prompt. Here I press Ctrl L to highlight the path, and I press CMD again. Once I'm here, I need to make sure to activate the environment that I created that contains the two libraries, OpenCV and Pygame. I type conda activate, followed by the name of my environment, which in my case is called Pygame environment. At the moment when you create this, you need to decide what the name is going to be. Then you will notice that left to the name of the directory or path, I now have the description of what the environment that I'm using is called. Now that I have this, I can run Python, and then I can call the main.py file. Now, this is the first thing that we need to remember. When you run the program as is, it will open your default webcam. Right now, my video streaming is running that webcam, so it may probably give me an error. So let's see what happens if I press enter. I actually have no idea. I've never done it before, but I presume it's going to give me an error. There it is. So it says basically that it encountered an issue with reading the frames. There's a lot of information with this log file, and it is actually giving us information directly from what OpenCV is. So let's try running the program again. This time, however, I get to choose the index of the camera as it is read in the system. What this means is that I can add the flag --CI, which stands for camera index. The camera index is going to receive an integer. So I add a space, and I can type 0, which is the default. So I know that produces an error. 1, in my case, is the droid cam, which I showed you before, and 2, which in this case is the GoPro that I have mounted in the microscope. For me, the only way to know this stuff is to basically just try multiple cameras and multiple indexes. This is really the only flag that you can pass to the Micrometry project. If I run the program this time, the camera that it shows me is not only available, but it's also the camera that refers to the GoPro. So here we have the same image that I showed you before. It hasn't changed. So now that I have the program, I can describe the different buttons. The first thing that we're going to do is to set the scale bar. This program is designed exclusively to generate lines. And if I click in line and I try to project a line, notice that the program doesn't give me any real value for that line. And the reason is because we haven't set a scale bar yet. So let's do that. I press escape, and then I click in the red button that reads a scale bar. Once I have the scale bar, very meticulously, I can click once to start the line and move it to the end of the unit of measurement that I'm going to be using. In my case, it's going to be 0.1 millimeter. And I click a second time to confirm. At this point, the clickings are not going to do anything anymore. The program is asking me to provide a length. And here is where I am going to type 0.1. If I make a mistake and I don't type anything, the program is going to show me an error, and I will have to repeat the process. Once I type something, I press enter, and the scale bar has been set. For me to know that this has actually happened, I click on the line button, and then I can start measuring elements. And you can see now that the line is producing also an estimate of how long my segments are. I can make it as long or as short as I want. Once I'm ready to take a measurement, let's suppose that I have this as my testing. There we go, almost there. And I can left click once more, just like with the scale bar, and I can type in the name, what the name of the measurement is going to be. Let's call this test at 0.1. And then I can press enter to confirm. Once the program finishes processing that information, it takes me back to the main menu. Now, what happened to that data? If you go back to your folder, you will find a file there that is called output.txt. Remember, we are inside of measure lines subfolder. If I double click in there, I will find the description of with the information on the measurement that I just created, how long it was and when it was taken. So really, it is the tag with the information that allows you to know what you were measuring and then the value of the measurement. But sometimes we want to have multiple projects. So I can go back and I can click on the third button that reads Set Path. Once I click on it, it will open the Save As dialog. Here, I can go anywhere in my computer. Let's go to the desktop, and I can create a new folder that is going to be called Project 1. Once I'm there, I can call this the test1.txt, and then I can click Save. Once this is set, any measurement that I make from now on is gonna allow me to save the data directly into that file. This is test2. I press enter, and notice that this time the output is not saved here, but rather in the project that I just created. Now let's level up a notch. What we're gonna do now is to capture images. So here we are, back into the main folder. I accidentally closed the program, so I need to open it again. I type command prompt. I activate my environment called Pygame environment, and then I can type Python main.py and camera index 2. That will reopen the program. Because I closed the program, I need to set the path once more. If you don't set the path, every information that you create will be stored in the default folder, which is where the repository was cloned. So I click in here, I say that yes, I want to replace this file. Otherwise, I would have called it something else. And then I can start taking pictures. Let's say that I take a picture of this. That's a really nice looking scale bar. So I can go back to the project 1, and you will notice that a new folder called images has appeared. I double click on it, and then I can find there my image. By default, the images are labeled with 6 digits. In future programs, depending on what the users require, I can create a version that will allow us to specify the name, the same name that you use with a measurement, to be also applied to the name of the image that you take. But I need to define the details first. At this stage, I'm not really sure what the needs for the program are. So that's pretty much it. As I mentioned, it's a really simple program. And now that we know how to run lines, let's move it up a notch and let's actually see how we can project Bezier curves. So let's close this program. Let's go back to the measure lines folder, and then I can go up one level. In here, I can click in the measure curves, and I'm gonna repeat the exact same process as before. Control L to access the path, CMD to access the command prompt, and then I can activate the Pygame environment. Oops. And once it's active, I can run the program. I type Python main.py, and the camera index2. Once the program opens, the first thing you will notice is that the setup is a little different. The scale bar is still there. The set path button is also there, and the picture. But now we have three different buttons. Let's start first by setting up our scale bar once more. So let's click on the scale bar, and then we can calculate the relationship of the distance per pixel. And here I'm gonna be very meticulous, trying to keep it straight as a straight line, like that. And I'm gonna say that this is 0.1. Now I can click on the Bezier curve. This replaces the straight line. The first thing that I want you to notice is that this is a lot like the Illustrator tool called Pen. This not only is part of Illustrator, but also many other programs that allows you to project vectors or lines or curves, is based on the principle of something called the Bezier curve. So I click on the left button first to set up the starting point of the curve, and then I can go anywhere I want from here, and then I press down a second time. But this time I don't release the button. I can click and drag it, and as I do that, you will notice that some helper lines have appeared. The line that ends in a circle that is opposite to where I have my cursor serves as the gravity point that pulls the otherwise straight line into a curve. So the more steep and far from the initial point and the ending point that center of gravity is, the more curve I get this original line. Notice also that the value of the measurements is now calculating what could be better described as a perimeter. So if I change my mind and I say, no, I want something that looks more like a line, I can keep going closer and closer to the center, and notice that the curve has turned back into a line. For now, I'm gonna project this curve. And then I'm gonna let go the left button of the mouse. Once I do that, if I hover my mouse around the screen, notice that a new curve has been created. This is now called a spline. The previous point where my cursor was is the new gravity point where my new curve is set to be bent towards. So here, because the previous point was over here, that's why my curve is moving upwards. But sometimes I may not want that. So I can click here and repeat the process, and notice that the information has been corrected. So now I have complete control over the Bezier curve, just like with Illustrator and Photoshop. But let's suppose now that I do like that curve because it matches perfectly the specimen, so I just want to confirm it. Let me release the button once more so that I get a really nice organic curve. And let's say that yes, that point and that curve match exactly to what I want. So this time I just left click once, but instead of dragging, I release the button immediately. And that will create the next line in the Bezier curve. Once I have it ready, let's suppose that I'm done and I don't want to keep adding more curves to this spline. I can press now the button D, as in dinosaur, and that is gonna confirm that the Bezier spline is done. Then, just like with the line, I can type the name, let's call it test, and then I can press enter. Now that the spline has been registered, I am taken back to the previous menu. Before we dive into what the other two buttons do, let's actually put a sample in the microscope so that we can see living organisms. Okay, so at this point, the sample has been mounted. I just put a drop of water from one of my tanks where I left a piece of food floating for a couple of days. So it seems that it has attracted, among other things, some really cool looking rotifers. And you can see them here. So if I am to navigate the space in here, we can see what looks like a paramecium perhaps, and some other organisms. Oh, there goes one rotifer. So let's start with one of these samples. And here we can encounter the first problem. When you are taking samples of dead stuff, it's not a biggie, right? Because you can measure it in any angle that you want and everything's fine. That's when the previous part of the tutorial was useful for. But when you are when you are dealing with alive organisms, then they hardly stay still in one same spot. So the button freeze allows us to take a photograph first, and then we are able to take the measurements that we need. So let's take a freeze in here. Notice that this process doesn't take a photograph that is safe in your computer, so just be mindful of that. And then I can click on the Bezier curve and I can calculate its perimeter. Very simply, I can just click and drag, and the spline, and the spline's behavior is very useful for this case. So I can just click and drag, and very simply, very fast, I can create an approximation to the perimeter of this organism. So now I have a finished value when I press D of 0.391. So I can call this para 01, and then I can press enter, and the value has been saved. Then I get confirmation and I am taken back to the original menu. Then I can click on freeze and I can keep doing my work. Now the edge button is a very special one. What it does is technically doing some object detection. So it will help you in the process of finding contours and finding organisms that are actively moving. If I press the edge mode, you will notice that everything turns black. At this stage, it's very important that I don't shake the microscope and I don't move the table, because if I do, I move the camera, for example, you can see that everything turns white because there is a change in the relationship of the pixels with their surrounding colors. This edge mode allows me to now see and detect the movement of the organisms that are in view. In the same way that before, I can also freeze the picture, and then I can go back to taking the measurements from the Bezier. In its simplest form, the Bezier curve also allows me to just trace a line, right? So there is just one simple line, and then I can just click and confirm. So it is the best of both worlds. Once I'm ready to continue, I can unfreeze this view, and then I can continue with my workflow. I don't recommend this tool when you're moving around, because then you completely lose track of what you're looking at. So we click on the RGB mode again, and we are brought back into the real world. And that's really it. That's the end of what Micrometry can do at this stage. What I would really like is, if you get the chance, I would really like for you to get in touch with me and let me know which particular needs you have. Right now, I'm about to expand it to also include a mode that allows for the gathering of data for future processing with machine learning applications. And I think that is really where the field is moving towards. So if you have any comments or you have any questions about this program, please don't hesitate to get in touch. You can again go to my website and find my contact information in there. I hope you enjoy.